I know that at the end of the last video, I promised that we're going to be talking about the batting strike rate as it relates to cricket in this particular video, right? I really apologize. I really have to talk about something called the 5-number summary before we develop a better understanding and to be able to use that metric called strike rate correctly. So in this particular video, we're going to talk about what is this thing called the 5-number summary. In statistics, we study 3 different kinds of averages: the mean, the median, and the mode. To find the mean of a given set of data, we simply have to add all the data items divided by how many data items there were. So for example, if we want to find the mean of the heights of 3 different people, we simply have to add up the heights, okay, H1, H2, H3. If they're the heights of 3 different people, we add the 3 different heights and we divide it by 3 because there were 3 data items. And this is what is referred to as the mean. Very commonly known as the average. When people say average, this is what they mean. The arithmetic mean. Okay, this is the formula for the arithmetic mean. This is one kind of average. The second kind of average is the median. The median for a set of data is the middle value after the data items have been arranged either in the ascending order or in the descending order. So it's the central value right at the center. The mode of a set of data items is that data value that occurs most often. Okay, so it is the data with the highest frequency. Regardless of which type of average is being used, the purpose of the average is to be able to describe the set of data. It is that one number that stands to describe the entire set of data. So for instance, if a class is going to take a math test, we often refer to something called what is the class average. So there will be an average that stands to represent the set of all the marks, the set of data, the set of all the marks that the students in that class have attained. Now, there will be students who have scored above average, more than the mean, or below average, less than the mean. So in order to have an accurate description, a complete picture of any set of data, just that one number called average is not a good indicator. So let me give you an example. If you have a set of data, I'm just going to draw a line, okay? Let's say this line segment, okay, represents the set of all the data items. This is the minimum value, small m. Capital M is going to represent the maximum value. The minimum value may be the lowest score, the lowest math score, and capital M represents the highest math score, okay? And somewhere in the middle, we are going to have what's called the median. Remember, we defined the median. I'm going to write the median here. That's right at the center, okay? Because that's the central value. And by the way, all these averages, whether it's the mean, the median, or the mode, are referred to as the central tendency or the central value because they stand to represent at the center of all these values that are arranged, in an increasing order in this case. So if all the data items are arranged in an increasing order, small n representing the minimum value and capital M representing the maximum value. Now, if this is what the entire data set represents, then we can also find 2 special numbers, something here and something here, such that you're going to have 25% of the data here, 25% of the data here, 25% of the data here, and 25% of the data here. And these 2 special numbers are called quartiles. Q1 is what we call the low quartile. Q3 is called the upper quartile. So we've got 5 numbers: the minimum value, the maximum value, the lower quartile, the upper quartile, and the median. And what is the purpose of these 5 special numbers? Well, when data is arranged in an increasing order or decreasing order, we can always make use of these 5 special numbers to then say that 25% of the data is anywhere between the minimum value and the first quartile or the low quartile. 25% of the data is between the upper quartile and the maximum value. And there is this 50% of the data, the mid 50% is between the low quartile and the upper quartile, often referred to as the interquartile range. Now, that's a lot of mathematics and a lot of mathematical jargon. I do understand. So let me try and relate all of this to the example that we were talking about in the earlier video. We were talking about batting averages, and we took the example of the number 1 T20I ranked batsman currently, okay, Mohammad Rizwan. And here, I want to talk about these 2 definitions. If you have not seen the video, I'm going to link that video. Please go and take a look at that, okay? I'm going to use the second definition. Why? because 2464 refers to the total number of runs scored by Mohammad Rizwan in the 63 innings. And I call this a redefined definition of the average. But the mathematical definition of average, as we have seen earlier, is the total number of data values. We talked about the three different heights, adding the three different heights, dividing by 3. Why? Because of the 3 different data points. In this case, if 2464 gives you the total number of runs scored in the 63 different innings, we have to divide it by 63, right? So this definition of the average is more mathematical. The other definition that is being used in cricket probably is just a comparison of the total number of runs divided by the total number of times he got out. Okay, so we are going to use this definition. And according to this definition, which actually represents the number of runs scored per innings, Mohammad Rizwan's average number of runs scored per innings is 39.11. And this 39.11 represents the central value of all the scores across the 63 innings that Mohammad Rizwan has played in, batted in, and scored 2464 as the total runs in all of those 63 innings, which means then that at the center, it may not necessarily be the median, we can write 39.11, okay? 39.11, the central value that stands to represent all the scores. If it were arranged, there's got to be a minimum value, the lowest score of Mohammad Rizwan in all of these 63 innings, the highest score in all of these 63 innings. And we can also calculate the low quartile, the upper quartile, and the median to give a more complete, a more accurate description for the scores of Mohammad Rizwan. So let me just show you what I've done on my calculator. I'll just jump back to the calculator, go through these different pages. I'll just show you. These are all the runs, okay? This is all the runs that he scored in each of those 63 innings. I've got it from the same Cricinfo website. So all the runs that I've put it up here. And then I made, this isn't actually about histogram, but this is not important. We won't talk about this thing here right now. That's the 5-number summary represented as what's called the box and whisker plot. If you want to see a video on box and whisker plot, I can link that video, but we won't talk about box and whisker plot right now. It's just a chart to represent these 5 numbers, okay? Here we go. This is the minimum value or the lowest score for Mohammad Rizwan. This is the lower quartile, which is 11 in this case. This is the median value, which is 33, and that is clearly less than the arithmetic mean. As you can see, there's a difference, right? 39.11 was the arithmetic mean, and the median is 33. And this is the upper quartile, which is 71, and his highest score is 104. Now, this is a lovely description using these 5 numbers, because what did I say? What does this do? 25% of his scores are in between those values. So 25% of the time over these 63 innings, Mohammad Rizwan his scores were between 0 and 11. 25% of the time in these 63 innings, Mohammad Rizwan's scores were between 71 and 104. And 50% of the time, the mid 50%, look at his scores range anywhere between 11 and 33. You can also say, 25% of the time, he scored anywhere between 33 and 71. So this is a more accurate, a more helpful description. So say, for instance, someone wants to find the probability, the chances. What are the chances that Mohammad Rizwan is going to be scoring, let's say, 50 runs? You can definitely say, hey, 25% of the time he scored between 33 and 71. So I think the chances are 25%. So what is the lesson to be learned? Well, one number alone, in this case, the batting average, does not give a complete picture of the entire set of data. But with these 5 numbers, this 5-number summary, the minimum value, the maximum value, the lower quartile, the upper quartile, and the median, we can give a better picture of an entire set of data. Now, statistics is not only used to describe an existing set of data, you can also use statistics to compare 2 different sets of data. And that is what we are going to do with strike rates in the next video.